Bismillahirrahmanirrahim. Welcome back to my channel. Let's do something on GNU Radio Companion. How you can make a basic flow graph and how you can do things with your GNU Radio. So, in order for me to do that, just simply open your GNU Radio Companion. Once you have installed it, just open it up. I'm using it in Mac OS. You can also use it in Windows and Linux platform as well. So just click on File, New. All right, so QT, no GUI, higher block. So basically the default is QT. Why QT? When you select QT, the reason you do that is this. Before, when GNU Radio started, it has a generation operation of WX GUI, but it will create a GUI which will based on WX. These were some instrumentation tools which GNU Radio was using previously. Now using QT, we have instrumentation related to QT. So think of it like this. Think of it like WX is an older version and QT is a newer version. So by default now in a newer version of GNU Radio, WX is completely gone. It's no more there. So the option is actually QT GUI. And based on this QT GUI, you're going to select your instrumentation tools like your time sync, your FFT syncs, and waterfall syncs, and histogram syncs, and things like that. When you first open this up, this is how a normal window of a GNU Radio Companion looks like. First block is actually a variable block, which is default. This is basically your sampling rate. So you're going to sample signal with respect to 32 kilo samples. This is how you're going to sample it. You can change this, but for right now we're going to leave it as default. How are you going to change it? Just simply click on it, double click on it, go here and just change the sample rate, let's say to 64 kilo. So you can type 64,000, or you can type it as 64e to the 3, which will change this into 64K. So this is how you're going to change this. So the first thing, which is like a hello world program for your GNU Radio, is actually go to your box here where you have all of your tools. So let me just zoom out and do Control F or Command F, and you want to take your signal source. So you're just simply going to write your signal source, or which is under waveform generators. As you can see it here in waveform generator, just simply double click on it. It will come onto your screen on your workflow flow graph. Let's get one more, and definitely okay, you want to connect to some instrumentation. You want to actually visualize the signal on your time scope or on your frequency sync. So just simply type in time sync. So here we go, we have time sync. This is your oscilloscope basically. So just double click on it, it will appear here, and just simply double click here and click, let's say I want to get frequency sync, which means your spectrum analyzer. So this is right here. So just simply double click on it and it appears right here on your flow graph. When you don't have physical device connected, which means, so now basically in real term, what is it that I'm doing? I have my generator, which is right here. I'm connecting it to oscilloscope. I have my generator right here. I'm connecting it to my frequency spectrum analyzer. This is what we're doing. Since we are carrying out simulation, I need to have a throttle block. Throttle block is nothing, is just simply a way to control the number of samples which are coming out, so you won't overload your CPU or your computer. So when you don't have physical device like your USRP connected to your computer, or you're not putting out this sound on your audio card or USRP or any type of software hardware platform which is not connected to your computer, you need to use a throttle block. Even though if you use it with your devices connected, it's perfectly fine. But it's just a way to control what type of number of samples, so you don't overload your CPU. So just simply double click on it, you'll get throttle block right here. Now the next thing that you need to do, let's zoom out. The next thing you need to do is this. Now it's easy for me to just simply connect these devices. So what I'll do is this. I'll take this and I click here and I click here. It will automatically connect this, or I can just simply hold on to my left mouse button and then drag it to my throttle block like this as well. I can do it like this. Simply I can just take this signal as is, put it here, hold on to your left mouse key, just simply drag and drop this wire, or I can just click here and I can click here, and then this will automatically connect these two blocks. So this block I'm gonna just by highlighting the wire, I can press delete, or I can press this to actually disconnect this, and just highlight the box and click on your keyboard D for dog. This will actually disable this block on your flow graph. Next thing is, I don't need this. I can just simply delete this by pressing this, highlighting it and pressing this. I can delete this, or I can just disable it. It will have nothing to do with the flow graph. Now, okay, so now GNU Radio works on data types. So if you were to click on it, so let's look at it. If you go to help and then you look at types, there are different types. So right now, if it's blue, light blue, this means you're in complex mode. Okay, when it's in orange, which means you're in a real mode, or a just plain old real mode, float mode, and there are different types. So right now, this is actually in complex type. You can change it into just the real part of the signal. Just double click on it and go to, so just double click on it on a block and it will come up with the properties of that particular block. Now what you need to do is this. Just go to complex, change this to float. As soon as you change this, the color of this output will change. Let me just move this. So when I change this to float, this color will change. And let's generate a cosinusoidal signal that has a frequency of 1000 kilohertz. Just click OK. So let's just zoom out, click OK. All right. Now, as soon as you have a different type, like for example, right now, this thing is float and this is complex, this wire connection gets red, which means there's something wrong with this. So I need to also change this. So I can just simply click here and then move my arrow keys on my keyboard. That also changes this. So just click on this, and by moving your arrow keys on your keyboard, this will also change the type. So right now it was blue, light blue. By moving my arrow keys, I can change this to float. As soon as the types are matched, you will get this wire to be black, which means there's nothing. Now there is also an error here, so I can just click, and by using the arrow key, change this. I can just simply go here, type float, apply, OK, do the same thing, complex, float, apply, OK. Now we're good. So this is basically sort of like a hello world program. So once you do that, the second thing that you need to do is this. You need to save this. So you're going to go here, save the current flow graph. I'm going to save it onto my desktop and I'm going to call it T1. All right. So I'm just going to simply save this with the name T1. Now as everything is saved, you will go to this play button, and this play button, what will do, it will run this flow graph. So when you press play, it will run this flow graph. Now what will happen is this. You will get a graph like this. You will get a graph like this. So basically in this flow graph, what is it that you're doing? You have a signal source that is generating a co-sinusoidal signal that has a frequency of 1 kilohertz and an amplitude of 1. It's going to my oscilloscope, which is known as time sync, and is going to my spectrum analyzer, which is known as your frequency sync. So I can see both of these flow graphs right here. Right here. I can see definitely by just moving onto your mouse, the wheel on your mouse, you can actually make this smaller or bigger, and by just holding your left button on your mouse and just highlighting this area, this will actually amplify this signal. All right, so this is how you do it. So as you can see, this is definitely a co-sinusoidal signal, and it's starting off with 1 going all the way up to 1. When I look at the Fourier transform of this, or when I look at this signal in my spectrum analyzer, this is what I would see, that indeed I do have a 1 kilohertz signal. So if I were to look at it, the spike is actually 1 kilohertz. You can actually look at it. So this signal is around 1 kilohertz. By zooming it out, as you can see, this is the actual signal that I'm interested in, because this is on the positive side of the spectrum. There is no such thing as a negative frequency. But if you have seen my tutorial on Fourier transform, this is actually comes due to Euler's identity. That's why. But this in physical device, you won't see the negative part. But this is in simulation, you can actually see that indeed you will get your F minus FC, F plus FC, and F minus FC. This is how you will get your signal. So this is how you actually visualize this. Now when I change this to complex, I can see both I and Q's channel as well by simply just changing it. Okay, now when I play this, now what do I see? I would see both of these. I would see real and complex, both of these signals together. So both of the signals, this is that complex and this is that real signal. So you would see both of these signals, and you would see a single spike related to 1 gigahertz. All right, so this is how you basically do it. Now let's do one more thing. Let's get an audio sync. Let's go here and type audio sync, and let's change this quickly to real. So I want to show you something. Real. All right, so just simply, okay, so if I don't have a throttle block, what will happen? So let's just first disable this by pressing D. Let's disable this and just simply connect one wire to this directly. There's just one wire. Okay, and let's just simply disable this. So now when I don't have my throttle, what will happen? Still, I am seeing some signal. That is perfectly fine, because my computer is able to handle the number of samples which are coming out. But when your flow graphs get bigger and bigger, and you have a lot of things going on into your flow graph, your computer will, the CPU of your computer will choke up. So that's why throttle block is important. Right now you don't need it, because it's just a simple signal. It's just one signal. All right, so now that's why you need to have a throttle block when you're running a simulation. Just keep that in mind. Now when I have my physical device which is connected, so let me just simply erase this. Okay, let me just close this. And just let me just disable this so I can just erase. I don't know, somehow it was not working. So just let me just enable this. Now let's have my audio sync. Connect my audio sync. Enable this and change the sample rate of my audio syncs to 40 kilohertz and apply. This is that normal generalized audio sync sampling rate for a 48 kilohertz, and just play this button. You will start hearing a tone. This is a 1 kilohertz tone. All right, this is how a 1 kilohertz tone sounds like. Okay, now let's do something else with my GNU Radio. Now the next thing I need to do is this. I want to make this frequency to be variable, which means I can control it on runtime. I can actually see how can I do that if I want to change this frequency during runtime. So the best way to do it is this. There's a thing called variable. Just simply type variable, and I think you will have variable sliders. Yeah, QT GUI range. This is the flow graph that you need. This is the tool that you need, a range. So just double click on it, QT range. Now what I need to do is this. Click here, change this ID to, let's say, F for frequency, and define the values here. So let's say our default value is 1 kilohertz. Let's say I'm starting my frequency at 500 kilohertz and I'm ending my frequency at 10 kilohertz, and I'm taking in a step of 100 hertz. Basically that's what it means. So my default range, which means the sound that I would hear by default, is actually going to be 1000 kilohertz, but I can have a variable that can go as low as 500 hertz and all the way up to 10 kilohertz, and it will take steps of 100. I'm sorry, this is where the steps will go. It will take steps of 100, but it can go up to 10 kilohertz. All right, this is what it means. So when you pick up these range blocks, it will allow you to actually change the frequency or change the amplitude during runtime. This is what it will allow me to do. So by just simply changing my ID to F for frequency, by having a default value of 1000, which is 1000 kilohertz, having a start frequency of 500 hertz, having a stop frequency 10 kilohertz, and taking steps of 100. So basically 500, then the next would be 600, 700, 800, 900. By clicking apply, click OK. All right, now I need to recall this here. So anything that you see underlined on your blocks, you can actually change this using your QT range block. You can change it using push button, label, entry, choose checkboxes. Anything that you would see underlined that can be changed during runtime using any of these blocks which are there in QT widgets. I hope you understood this. So now I'm changing frequency, so instead of 1000, I'm just gonna simply write F now. So now this F, so as soon as I change this to F, whatever my default frequency was, which was 1 kilohertz, that is there now. Now I have a capability, so I can start changing sound and I can change the frequency during runtime. So when I press this play button, okay, now I'm hearing a frequency of 1000 kilohertz. Now I can go as low as 500 hertz. So when I go, this is 900, this is 800. I hope you can hear this. This is 700, 600, and 500 hertz. Now let's go up to, let's try to go up to like 1000 hertz or 1000, not 1000 hertz, I would say 1000, 10,000 kilohertz or 10,000. So just hold on. So just by changing the frequency, you can see the change in frequency. You can easily see the change in frequency, so you can hear this. this is that 10 kilohertz, which is quite bothering to your ears. You can just simply select this and change this to, let's say, 500 hertz, and then just hit enter, and then randomize this. So in this way you can use a block like GUI range to actually change the frequency or amplitude at the same time. So let's just quickly do it for the amplitude real quick, and then we will end this tutorial because it's getting quite longer and lengthier. So just simply I'm gonna copy this and I'm gonna paste this here, and I'm gonna call this, instead of this I'm gonna call this amp A for amplitude. Let's have a default of 1, and let's have a start of 500 milli e to the -3. I can do that, and stop at about 10, and let's go into increments of 500 e to the -3. Click apply, click OK, and just go to your amplitude and click A. As soon as you click A, now this has changed. Now just simply click play button. Now you have your frequency, which is still at 1 kilohertz. Now I can change the amplitude. You can clearly see you have an increase in amplitude, which means increase in sound. So this is how you can use range blocks in GNU Radio to actually manipulate your frequency and amplitude during runtime, so you can clearly see what's going on with your signal. So I hope you like this small and lengthy and boring tutorial. If you have any questions, leave it in a comment section, and don't forget to like and subscribe to my channel.